All right, section 6.5 continues with the whole concept of factoring, and we are going to be factoring binomials. Now, there are really two different kinds that we're going to look at. There are three branches in the flow chart, but it's really only two different kinds. The first kind that we're going to look at is the difference of squares. And just like I usually do when we start something with factoring, is that I review the multiplication that leads to this particular kind of polynomial. So let's review. What if I ask you to multiply x plus 3 times x minus 3? Do you remember what you call it when you multiply a binomial with a plus and a binomial with a minus and the same quantities? You might or might not remember what it's called. It's called a sum and difference product. Sum, the plus sign, difference, the minus sign. It's the product of those. When you do it, think about doing it by FOIL. What's the product of the first? X squared. What's the outer product going to be? Negative 3x. What's the inner product going to be? Positive 3x. So I'm going to have a negative 3x and a positive 3x. Those are opposites, which means you get 0. You don't have a middle term to write down. What's the product of the last? Minus 9. A sum and difference product. Because of the plus and minus of the same quantities, the outer and the inner product are always opposites. They always cancel out. So I end up with a first term minus a last term. I end up with the difference of squares. Let's look at one more. What if I had 2x plus 5 times 2x minus 5? What's the product of the first? Won't it be 4x squared? Outer product, inner product, I don't care because they're going to be opposites, whatever they are, so I'm not going to waste any time on them. What's the product of the last? Minus 25. So when you multiply a sum and a difference of the same quantities, you get the difference of squares. So our job is now going to be able to take the difference of squares and discover what the factors were. All right, you need to be able to recognize perfect squares. Okay, a number and its square. Whoops. All right, 1 squared is 1. 2 squared is 4. 3 squared is 9. I know you know this, but I'm just going to go ahead and create the list. 4 squared, 16. 5 squared is 25. 6 squared is 36. 7 squared, 49. 8, 64. 9, 81. 10. 100, 11, 121, 12, 144, 13, 169, 14, 196, 15, 225, and I'm tired. Dot, dot, dot. And you could go on with this. You need to be able to recognize that a number is a perfect square and either know what its square root is or be able to do it with your calculator. A variable is a perfect square if its exponent is even. Okay? And it could be a higher power. What if I had x to the 6th? That's a perfect square because its exponent is even. What would its square root be? X to the 3rd. Okay, so all of that's going to come into play as we look at problems. So let's go ahead and look at the MyMathLab questions that have to do with the difference of squares. The instructions for these say, factor the following binomial completely. Okay, so I am in 6.5, number 1. What if I had x squared minus 64? If I'm asked to factor that, first thing I do is look at the terms and say, is there a common factor? No. Then I say, okay, well, there's two terms. It's a binomial. At this instant, I only know one kind of binomial to factor, and that's the difference of squares. Is this the difference of squares? Is it a difference? Yes. Is that a perfect square? Is that a perfect square? The factors are going to be two binomials. One of them will be plus, one of them will be minus. Remember, I'm going to get a sum and difference product. It is the sum and difference of the square roots. What's the square root of x squared? What's the square root of 64? So I'm going to get x plus 8 and x minus 8 as my factors. It's an easy pattern. It is the sum and the difference of the square roots. No trial and error. Certainly you can check it with FOIL. Product of the first is x squared. Outer product, negative 8x. Inner product, positive 8x. Gone. Product of the last, minus 64. Okay? So let's practice. These are easy when you recognize that they are difference of squares. Number 2, how about 49x squared minus 1? Is there a common factor? No. Is it the difference of squares? Yes. So if it's the difference of squares, then I know I'm going to get 1 plus and 1 minus. What will the first be? 7x plus 1, and then 7x minus 1. Done. All there is to difference of squares. Would you do number 3? How about 9x squared minus 64? Okay, there's not a common factor, but it is the difference of squares. So what'd you get for the first factor? 3x plus 8 and 3x minus 8. You'll take a whole test of these, won't you? All right, number 4. 121x squared minus 225y squared. There's not a common factor. Is it the difference of two squares? Yes. Okay, may not have left myself enough room to write. All right, 1 plus and 1 minus. What's the square root of 121x squared? 11x. And the square root of 225? 15y. So it would be good to know where the square root key is on your calculator so you could check things if you needed to. All right, number 5. I have 49x squared plus 36. All right, there's no common factor. Is this the difference of squares? It's the sum of squares. The sum of squares is prime. In MyMathLab, you would just put a P. So the sum of squares is prime. If you tried to factor it, if you want to, have a debate, you think it could be factored. Because this last number, the last term is positive, that means both factors have to have, the sign of the middle, which doesn't exist, but suppose you pick something, 2 pluses. You're going to get a middle term. I mean, you could play with it. If you thought it was 7x plus 6 times 7x plus 6. You're going to get an outer product of 42x and an inner product of 42x, which is 84x, and it's not there. If they were both minuses, which is the only way that you're going to get this plus 36 is to have these two have the same sign, you're going to get a minus 84 for the middle term. There's no way, unless you did a plus and a minus, that you can make the middle term go away. And if you had a plus and a minus, that would be minus 36, the difference of squares. So, sum of squares is prime.
So is that going to be anytime you have a plus sign?
Yes, if it's a square plus a square, it's prime. Okay? Problem 6 asks you to take things just a little bit further. You've got m to the fourth minus 81. This is a difference, so that's good. Is m to the fourth a perfect square? Yes, because it has an even exponent. And 81, is that a perfect square? Okay, then I will begin. And one of these will be plus and one will be minus. What's the square root of m to the fourth? Yes, m to the second. And the square root of 81 is 9. Now, because this exponent was bigger than a 2, then I've still got m squareds. This factor is a prime factor because it's the sum of two squares. I definitely cannot do anything more with it. But this one is the difference of squares, isn't it? So I can factor that factor further. How does that factor? M plus 3 and m minus 3. Now, the only factor that's got a minus is this last one. Is it still the difference of squares? No, because the exponent is no longer an even. It's an implied 1. When the exponent is no longer even, then you have no more chance at it being a difference of squares. But you would have to have all of these factors to get credit for this question. Not a likely test question, but there is one in MathLab. All right, let's look at number 7. What if I have x to the 4th minus y to the 14th? Is that the difference of squares? Yes. And how did you know that those were both perfect squares? They're both even. All right. So one of these will be plus and one will be minus. The first one will be x to the 2nd plus y to the 7th. So when you take the square root of that, you're just taking half of its exponent. The other one will be x to the 2nd minus y to the 7th. Is this factor still the difference of squares? The answer is no, because that exponent is an odd number. So I can't take half of it, which is what I do to get the square root. Half of 4 was 2, half of 14 was 7. But now that I'm left with x to the 2nd, yes, that's a perfect square, minus sign, looking good, y to the 7th blows up, because I can't take half of 7 and get an integer.
I have a question with the square root of 14.
No, the square root of y to the 14th is y to the 7th. Because when you take the square root of a base with an even exponent, you cut the exponent in half. But the square root of 14 is not 7. Okay? So this one is done.
So even if you got one even exponent and one odd,
You can't do it?
One odd and that throws it out.
Yes. Okay? So are y'all okay on the difference of squares? Difference of squares always factors into the sum and difference of the square roots. The second kind of problem in this lesson is the sum or difference, and I'm going to abbreviate that, of cubes. The sum or difference of cubes. Now, please notice the big change. When it was squares, you could only factor the difference of squares. But when it comes to cubes, we're going to be able to factor the sum or the difference. Okay, I would say first thing we need to do is remind ourselves, what do cubes look like? Squares we tend to recognize. Cubes, I don't know. If you have a number and its cube, let's see. Well, x, the cube of that is x to the third. Okay. Now what if I had 1? 1 to the third power is still 1. 2 to the third power is 8. 3 to the third power, 27. 4 to the third power, 64. These get real big real fast. 5 to the third power, 125. 6 to the third power, I think it's 216. 7, 343. And I'm going to stop. You will want to know where on your calculator you can take a cube root. So if at the end of class, if you'd like me to help you explore your calculator, I may or may not be familiar with it, but together we should be able to figure it out. Where is the cube root key? And sometimes you don't have a cube root key. Instead, you might have an nth root key, and you have to tell it to put a 3 where the n is. And that would be nice when you see a number and you say, yeah, I think that's a perfect cube. And then you could just punch it in the calculator and find out. Okay, so I will help you with that if you need help. Sum or difference of cubes. Let me go ahead and write down the patterns, and then we're going to practice on problems. These are going to require you to memorize a little bit, just a little bit. It is a pattern, but you have to memorize it. Now, it was real easy to memorize the pattern for the difference of squares. It is the sum and difference of their square roots. It's a little different with these cubes, but here we go, the pattern. Luckily, it's the same pattern whether it's the sum of 2 cubes or the difference of 2 cubes. It doesn't matter. The pattern turns out to, you say the same things. All right, let's start out with, what if you have x cubed plus y cubed? Would you agree that that is the sum of 2 cubes? Perfect cube plus a perfect cube. All right, the way you factor it, and you're going to have to take my word for it to start with, is a binomial times a trinomial. Binomial times a trinomial. In the binomial, what you always start out with is the cube root of the first one, x, the same sign, plus, and the cube root of the last one, y. So it's always the cube roots with the same sign. Now, creating this trinomial, it took a while, even as a teacher, for me to figure out, now how am I going to remember this? I can't walk into class and not have it memorized. You know, but when I was at a learning stage where y'all were, I never had a way to put it into long-term memory. I could only remember it short-term. And so finally I came up with a method, and now I share that for what it's worth. The first spot in the trinomial, by the way, I'm going to use these to build my trinomial. I'm using these. All right, the first spot is the square of the first. So take this first, square it, x squared. Then I'm always going to change the sign. So if this is a plus, I'm going to put a minus. If this is a minus, I'm going to put a plus. I'm always going to change the sign. Then I'm going to write down the product of these two. X times y is xy, product. And then the last one is always the square of the last. Take this and square it. Squares are positive, so it's plus y squared. So it is always square, change the sign, product, square. And that's the little thing I say to myself. Square, change the sign, product, square. Okay? Now, suppose that instead I had x cubed minus y cubed. You'll see that I'm going to do all the same things. It is the difference of two cubes. So it's going to factor into a binomial times a trinomial. In the binomial, cube roots keep the sign. X minus y. Is that much okay? Keep that sign. Now, I'm going to say the word square. Square the first one. X squared. Change the sign. Plus product. X times y. Square the last one. Plus y squared. Now, if you just look at this pattern up here and look at the second pattern, at least for me, it's a big jumble of signs and letters. And I'm like, oh my gosh, I could never remember that. What I have to remember is how to create the binomial. Cube roots with the sign. And then 4 expressions. Square, change the sign, product, square. And it will always work out. So, yes?
In the first, what is the first time you keep the positive sign?
Yes, because when you square something, now wait, are you talking about this sign from here?
I'm talking about the y squared.
The y squared. It will always be positive because no matter what's going on here or here, when you square it, it's positive. So the last sign is always positive. All right, so let's look at MyMathLab. And these problems would start with number 8. I have y cubed plus 27. When you're asked to factor, first thing, is there a common factor? No. Second thing, count the terms. It's a binomial. We have 3 choices. Is it the difference of squares? No. Is it the sum or the difference of cubes? Yes, it is the sum of 2 cubes. I don't really care whether it's the sum or difference of cubes because I'm just going to use my pattern. Binomial, trinomial. In the binomial, cube root of y cubed is y. Keep the sign plus, what's the cube root of 27? 3. I now use these terms of the binomial to build the trinomial. And the words are square. Square the y, it's y squared. Change the sign, goes to minus. Product, 3 times y is 3y. Square the last, plus 9. Now, let me mention, nobody's asked, because it's our first one, this trinomial sort of looks like a little bit like a perfect square trinomial, because there's a perfect square and there's a perfect square. The middle term is never the right middle term. The trinomial you get is always finished. You won't be able to factor it any further by trial and error. It's a prime. Done.
Can you tell me how you got the
The 9?
Yes.
I took this 3 and I squared it.
Okay.
Okay, so that's 3 to the second power. Okay? Let's look at number 9. I have 8x to the third minus 125. Is there a common factor? No. It's a binomial. Which kind of binomial is it? difference of cubes. Okay, so I need binomial times trinomial. What's the cube root of 8? 2. So that's going to be 2x. Keep the sign. And what's the cube root of 125? 5. So you either need to be able to recognize those, or you need to be able to use your calculator to figure them out, that those are perfect cubes and what are their cube roots. Now I'm going to use these to fill in. The first one is a square. What is 2x squared? When I multiply 2x times 2x, I get 4x squared. And then I'm going to make that go away. So take the first one, 2x, multiply it times itself, that gives us 4x squared. What's the sign? Plus product. Now, you've already taken care of the sign, so ignore the signs. 5 times 2x is 10x. And then the last one is square the 5 for 25. Done. Now, I haven't been checking these. They're not a lot of fun to check. You would have to use distributive property and multiply 2x times 4x squared times 10x times 25. Then you would multiply negative 5 times 4x squared times 10x times 25. All the terms except 8x squared and negative 125 will drop out. You can take time to show yourself that if you want. All right, let's look at a few more. Number 10. What if I have q to the third plus 216 r to the third? There's not a common factor. I see some exponents of 3, so I'm thinking cubes. Is 216 a perfect cube? Yes, it is. So I'm ready to do my factoring. The cube root of q to the third is q, plus sign. The cube root of 216r to the third is 6r. And that might be one of the numbers, as they've gotten larger, that you're going to want to be able to put it in your calculator. Okay, would you go ahead and create the trinomial, and then we'll do it together. Y'all go ahead and do it. Okay, let's use our pattern. Square. What will I write down? Q squared. Change the sign. Minus product 6QR. Square the last one. Plus 36R squared. A very common oversight is to leave off the square on the variable. That's a common mistake, but try not to make it. Is that okay? All right. Let's look at 11 and see how things begin to change a little. I have 6x to the third plus 48. I think the first thing you might notice is, okay, yeah, I see that cube, that really jumps out at me, and I start thinking sum of cubes, but that's really not what I'm supposed to think first. What am I supposed to think first? Greatest common factor. And you probably would have gone there anyway because 6 isn't a perfect cube, and neither is 48, so either the numbers are messed up or there's a common factor I can factor out. Let's factor out the 6. Instead of working this way, I'll go down. All right, if 6 is a common factor, and I divide both of these by my 6, that will give me x to the third plus 8. Can I do more with that binomial factor? Doesn't that look like the sum of two cubes? So I'm going to keep the 6. Don't lose it. And then I'm going to look at binomial times trinomial. Cube roots. Cube root of x to the third is x. Keep the plus sign. Cube root of 8 is 2. Now I'm going to use those quantities to create the trinomial. Square x squared. Change the sign. Minus product 2x. Square the last. 4. You have to have all of that. Don't lose the 6. So sometimes there is a first step of greatest common factor before you use one of your other skills. All right, let's look at number 12. I have 128 x to the third minus 2y to the third. I'd like you to think through all the possible steps and factor that. What did you see first in this problem? Greatest common factor, and what can I factor out? A 2. Okay, so if I divide each of these by 2, I'm going to have 64 x to the third minus y to the third. I look at the binomial that I got, and does it fit one of the categories? It's the difference of cubes. Don't lose the 2. The cube root of 64 x to the third is what? What's the cube root of 64? 4x. And the cube root there, I put a minus y. Now you have to be careful. 64 is kind of a sneaky number. 64 is a perfect square. Its square root is 8, but it's a perfect cube. Its cube root is 4. So there aren't very many numbers that are like that. Now, how do I create this? Square the first. 4x times 4x, 16x squared. Change the sign. Plus product 4xy, square the last, plus y squared. You need all 3 of those factors. Don't lose the 2.
So the first time, first parentheses, you don't square anything?
No.
I mean, don't use
No. You actually take the cube root of 64x to the third, and you take the cube root of y to the third to get these. Nothing is squared there. And then this one's a square, and this one's a square. Okay? The last 3 problems in the lesson, go back, they review difference of squares, nothing new. So there are 15 questions, but we've just stopped at number 12. So I hope you're okay. You've got 3 things to know: the difference of squares, the sum of cubes, and the difference of cubes. But the cube patterns are the same. Okay?